Imagine a time, before stars, before galaxies, before anything we currently know. This was the state before the Big Bang, a realm of pure unformed potential. Everything we see was yet to be. What was there? It was not nothing. It was something beyond our daily grasp. All energy, all future matter, packed into an unbelievably tiny point, smaller than any atom, hotter than anything imaginable. A cosmic seed, infinitely dense and energetic, waiting for its designated moment to unfold. The universe, in essence, held its breath. This singular point held absolutely everything. All of space as we know it, all of time. They were not separate concepts then. They were intricately bound together tightly, a single unified and unimaginable state. There was no outside for it to exist within. It was, in itself, the entire universe. The cosmic stage was meticulously set. Then it happened. The Big Bang. But it was not an explosion in space, like a bomb going off somewhere. No, it was an expansion space itself. Everywhere, at the same instant, space began to stretch, to grow, a new kind of beginning. Imagine a tiny, folded-up balloon. Suddenly air rushes in very fast, the balloon's surface expands rapidly. Points on the surface move apart, not because they are racing across it, but because the fabric itself is stretching. This is like our early universe. Space itself was the thing expanding. In the very first moments, it was hot, unimaginably hot, and incredibly dense, a searing plasma of fundamental particles, too hot for atoms to even form. The universe was an opaque, energetic fog. As the universe expanded, it cooled. This cooling was critically important. Energy began to transform into matter. Einstein's famous equation tells us how E(mc)2. Energy and matter are two sides of the same coin. Tiny particles began to appear. Quarks, electrons, these are the building blocks of everything. The universe was a particle soup. Slowly, over hundreds of thousands of years, the universe cooled enough for more change. Protons and neutrons formed from quarks. These then combined to make atomic nuclei, mostly hydrogen, some helium, the simplest elements on the periodic table. For a long time, the universe was dark, filled with these atoms, but no stars yet. After about 380,000 years, a milestone, the universe cooled enough for electrons to combine with nuclei forming neutral atoms. Suddenly light could travel freely. The universe became transparent. We see this light today. It is the cosmic microwave background. Section 4. A pale blue dot, Earth's precious harbor. Billions of years passed, stars lived and died. New elements were forged in their fiery hearts. Our own star, the Sun, formed about 4.6 billion years ago from a vast cloud of gas and dust left behind by older exploded stars. This cloud also formed the planets, including our home, planet Earth. Earth formed in a special place, not too close to our Sun, not too far away from it either. We call this the habitable zone, or sometimes the Goldilocks zone, just right for liquid water to exist. Water is essential for life as we know it. This location is key to Earth's story. Our planet's size also matters greatly. If Earth were much smaller like Mars, its gravity would be too weak. It could not hold on to a thick atmosphere or its precious surface water. Section 5. Our galactic neighborhood lost in immensity. Our Earth is just one planet. It orbits a rather average star, our Sun. The Sun is our local powerhouse, providing the light and warmth for life. But it is just one star among billions, many, many billions in our galaxy. Our solar system is a tiny speck in a much grander cosmic structure. Our Sun resides in the Milky Way galaxy, a majestic spiral of stars, gas, and dust. Hundreds of billions of stars, perhaps more. Our solar system is in one of its spiral arms, about 2/3 of the way from the center. It takes our Sun about 230 million years to complete one orbit around the galactic core. That is a long, long journey. And our Milky Way galaxy, it is also just one among many. Billions of other galaxies spread throughout space. Some are spirals like ours, some are ellipticals, some are small, some are truly enormous. They stretch out as far as our telescopes can see. The observable universe is vast, filled with an estimated 2 trillion galaxies. Think of the scale. Section 6. Children of the stars, forged in cosmic fire. When the universe began, there was only hydrogen and a little bit of helium. These are the lightest, simplest elements. Look around you, look at yourself. We are made of much more complex stuff. Carbon, oxygen, nitrogen, iron. Where did these heavier elements come from? The answer lies in the stars. Stars are cosmic furnaces. In their cores, incredible heat and pressure fuse lighter elements into heavier ones. Hydrogen becomes helium, helium becomes carbon, and so on, up the periodic table. This is stellar nucleosynthesis, how stars create new atoms constantly. They are element factories in the sky, but many heavy elements like gold or uranium require even more extreme conditions. These are formed in the death of massive stars. When a giant star runs out of fuel, it can collapse and then explode, a spectacular event called a supernova. Section 7. The Universe Within, Knowing Our Origins. The story of the universe is our story. From the Big Bang's first moments to the formation of stars and galaxies, to the birth of Earth and life, it is an unbroken chain of cosmic evolution. We are a part of this grand narrative, a very recent yet significant part. Our existence is a testament to this journey. Understanding the universe helps us understand ourselves. It tells us where we came from, what we are made of, our place in the cosmos. This knowledge is profound, it is humbling, it connects us to everything around us and to everything far beyond our world. The atoms in your hand were once inside a star. That star exploded, seeding the cosmos. The quest to explore the cosmos is ancient. It is driven by human curiosity, our innate desire to know, to understand. When we look up at the night sky, we are looking back in time and we are looking at our own origins. Science is our tool for this exploration. It allows us to piece together this amazing story.